Hello everyone. In this video, we will see the fundamentals of spatial filtering. So here the spatial filtering, it is one of the principal tools which is used in the image processing, and these filters are generally used for the image enhancement. The filters usually refers to passing or rejecting some frequency components, and here we are dealing with the low pass filters that will pass the lower frequencies. So here the overall effect of the low pass filter, it is to blur the image or smoothing of an image. So here we can accomplish a similar smoothing directly on the image itself by using the spatial filters. And these filters, that is the spatial filters, are also called as spatial mask, kernels, templates or windows. So the special filters offers considerably more versatility compared to than that of the frequency domain filters, and because of this reason they are used for non-linear filtering. So here the special filters, these consist of a neighborhood, which is typically a small rectangle, and a predefined operation that is performed on the image pixels, which is associated with the neighborhood. And the filtering, that is this special filtering, these will create a new pixel with the coordinates equal to the coordinates of the center of the neighborhood, and whose value will be equal to the filtering operations. And the processed image, that is nothing but the filtered image, which is generated, it is it is the which is generated, it is the center of the filter. As the center of the filter visits each pixel in the input image, okay, this filtered image, it is generated as as the center of the filter. Okay, the center of the filter visits each pixels in the image, that is will be moving the filter or the kernel over the image, and we will calculate the we will generate the new image, that is the processed one or the filtered image. Now this is the figure which shows the mechanics of the spatial filtering or the special filter. So here this process consists of a mask. This is the mask, which will be moving on the image. Okay, that is from point to point. From this point to point, this mask will be moving, and at each point of the response of the filter, at that point it is calculated by using a predefined relationship. So here what we'll do, we'll move the filter mask from point to point in the image. Now for linear filtering or the linear spatial filter, the response which is given by g of x comma y, or you can even denote it as r, it is given by the sum of the product of the filter coefficients, that is the kernel coefficients w of -1 comma -1, and the coefficients in the image pixels. These are the coefficients in the image pixel. You have to find the product of these, and you have to go on adding. That is, this will be multiplied. The first one, this is the first pixel here. That is w of -1 comma -1 is multiplied with f of x -1 comma y -1, plus similarly these two, plus similarly these two, and so on up to the last one. So here suppose here what we are doing, we are taking a mask of size 3 cross 3, that is there are 3 rows and 3 columns here. So the result of the response of this linear filter, it is a linear filter at any point x comma y. Okay, it is given by using this formula here, and this equation, it is nothing but the sum of the product of the mask coefficient with the coefficient of the image pixel value. This is the mask coefficients, that is the kernel coefficients, and the coefficients of the image pixel value. Next, if we have this equation, suppose if we see this equation here, you can see w of 0 comma 0 into f of x comma y. This point, it indicates that the mask is centered at f of x comma y. Okay, it is centered at f of x comma y. So for a mask of size m cross n, we'll assume that m value is equal to 2a plus 1 and n value is equal to 2b plus 1, where a and b, these are non-negative integers. Okay, and this indicates that here, this indicates that the mask is of odd size. That is, if we give here A is equal to 1 and B is equal to 1, then this will become the mask size will become 3 cross 3. So it will be odd. Okay, so mask size will be odd when we substitute A is equal to 1 and B is equal to 1, as the mask size will be 3 cross 3. So in general, that is in general linear filtering of an image, the image size will be capital M cross N and the mask size will be small m cross N, and then it is given by this equation. Okay, so the general linear filtering image of size m cross n and mass size small m cross n, it is given by this equation, where you can calculate the value of A from these from this equation and value of B from this one. So A will be m minus 1 by 2 and B will be n minus 1 by 2. So here this equation, that is this will consider as the first equation, this as the second equation. So here this equation number 2, it is similar to that of the frequency domain concept, that is nothing but the convolution. Therefore, for this reason, the special filtering, that is a linear special filtering, it is often referred to as convolution mask, or it is called as convolution kernel. Okay, and here we can write this equation 1 as r is equal to g of x comma y, that is equal to w1 z1 plus w2 z2 and so on up to wmn z of mn, where this w, small w, it is a mask coefficient, then z, it is the value of the image gray level, and m cross n, it is total number of coefficients present in the mask. So this equation, will take it as equation number 3. Now this equation number 3, it can be written as, that is, you can sum up and write it as r is equal to summation I is equal to 1 to mn wi z I. Now we will take a mask. Suppose this is a mask of order 3 cross 3, and that is a mask coefficient yes, and corresponding image pixel values on which the operation is performed is shown in this figure. So here what we'll do is we'll multiply these, that is w1 z1 plus w2 z2 w3 z3 up to w9 z9 here. Okay, so we'll get this as r is equal to w1 z1 plus w2 z2 and so on up to w9 z9. So in general, we can write this as r is equal to summation I is equal to 1 to 9 wi zi. So once the operation is performed, the value of z5, so this is nothing but the center, the value of z5 will be changed after the process is completed. Similarly, you have to find out for all the points by moving the kernel over the image from point to point. This is about the spatial filtering. I hope you have understood and enjoyed the video. Thank you.